What do you mean by sampling and sampling theorem? Before this, we have already studied about analog communication, amplitude modulation, frequency modulation, phase modulation. Then why do we need sampling in analog and digital communication? Yes.
मैम कंटिन्यूस सिग्नल को डिस्क्रीट सिग्नल में कन्वर्ट करने के लिए
Okay. To convert the continuous time signal to discrete time signal, that's why we need sampling. That is the process of sampling. What is the requirement of sampling? क्यों हम कन्वर्ट कर रहे हैं एनालॉग सिग्नल को डिजिटल में इफ वी ऑलरेडी हैव एनालॉग सिग्नल?
मैम इंस्टेंटेनियस पॉइंट्स पे उनकी वैल्यू नोट करने के लिए
एनी अदर एडवांटेजेस? Yes, friends. Any one of you? We all know.
Map to measure instantaneous value.
Okay. Or yes, lead students. Customer.
Yes, ma'am.
सैम्पलिंग क्यों यूज कर रहे हैं? Why do we convert the analog data to digital?
Uh,
Now this is an example of sine signal. It's a continuous time signal. After converting it into discrete time or its sampled form is like this. You can see here the shape and resemblance of both the signal remains same. Just we have to convert the continuous time signal to discrete. अब हम continuous time signal को discrete में क्यों convert कर रहे हैं? Because of the use of the digital technology. आप देख सकते हो जो latest जो भी technology that is digital in nature. In real life examples also we require digital signal. That's why we use sampling. Is that clear?
yes, ma'am.
And we already studied about advantages and disadvantages of digital communication or discrete time signals also. Means advantages of DSP over ASP or advantages of analog communication of digital communication. Digital communication में क्या है? You can secure your data. Easily secure कर सकते हैं. Privacy is there. Long distance communication is also possible in this. But in analog communication, for a long distance communication, the implementation of transmitter and receiver is very difficult. That's why we use sampling. Now, how to perform the sampling? The definition of sampling is to convert the analog signal to digital. How we can do it? Because at the input we already have continuous time signal. अब क्या करें? How to perform the sampling? Yes, friends. Say yes or no. I'm audible.
Yes, ma'am.
क्या था sampling? To convert the continuous time signal to discrete signal or its sampled form is called as sampling. अब कैसे perform करें sampling? How to perform? Yes, Arun. अमनदीप, पढ़ी है सैम्पलिंग आप लोगों ने पहले? सी यस और नो? सोनिया,
Yes, ma'am.
जी पढ़ी है सैम्पलिंग?
हाँ जी मैम.
अब मैंने बोला कि सैम्पलिंग क्या है, कंटिन्यूस टाइम सिग्नल को डिस्क्रीट टाइम सिग्नल में कन्वर्ट करता है। अब कैसे परफॉर्म करें सैम्पलिंग? हाउ टू अचीव डिस्क्रीट टाइम सिग्नल थ्रू सैम्पलिंग?
Ma'am, P.
हाँ जी, x of t is our continuous time signal at the input side. Then क्या करें कि आपके पास सैम्पल्ड आउटपुट आ जाए, that is in the discrete form. Any one of you? Arun,
मैम सैम्पलर लगाएंगे।
सैम्पलर लगाएंगे। क्या करेंगे? सैम्पलर को एक इनपुट दोगे, कंटिन्यूस टाइम सिग्नल, that is your x of t, and second is c of t. What is c of t? That is the impulse train impulses of impulse signals. We have already studied about impulse signal whose value is 1 at t is equal to 0. If at t is equal to 1 its value is 1, that is called impulse delayed signal, that is delta t minus 1. Am right? Yes students.
यस मैम।
अगर मैं 2 पे 1 कर दूं, that means the value of the signal is 1 at t is equal to, that means it's a delayed by 2 units, that is delta t minus 2, up to so on. So it's a train of impulse signals or train of pulses. Similarly you can write here कि -1 पे value 1 आ रही है, that means it's a delta t plus 1 advanced by 1 unit up to so on. अब एक सिग्नल x of t दिया, suppose it's a sine signal, and second one is your c of t signal, that is a impulse train of signal. We have to pass these two inputs through a sampler. अब sampler क्या करेगा? Produce an output that is s of t. अब s of t क्या होगा? That is to convert the continuous time signal to discrete time, but in its sampled form. If I'm talking about the signal that is continuous in nature, so you can see here, this signal continuous in nature ही है, dotted one, but जो इसके samples हैं वो sampled form में आए, that is discrete in nature. Is that clear? What is sampling? How to perform the sampling?
यस मैम।
ये stressed all students, अब तो respond करोगे? We have already studied this and signals and system. X of t, or we can say m of t, is our message signal, that is a band limited signal. Band limited means जिसे जिसका band हमने limit किया frequency को, suppose वो -t to t जा रहा है, that is called band limited signal. And what is the purpose of sampler here? That act as an multiplier, that is used to multiply two signals. मैंने अभी लिए थे x of t और c of t, तो यहाँ पे m of t और c of t को मल्टीप्लाई करेंगे, जो आउटपुट आएगी that is s of t. and you can see the shape of both the input and output that is same, but at the output side we achieved sampled form of continuous time signal. And how we can achieve it? With the help of this impulse string. अब इस impulse string में देखो 0 पे amplitude 1 है, TS पे amplitude 1 है. What is TS? That is called sampling time, sampling period. And what is omega s? That is equal to 2 pi by TS. That is sampling frequency. Now any question in this, how to perform the sampling? Yes.
No, ma'am.
That is your definition of sampling. The process of converting continuous time signal into equivalent discrete time signals is called as sampling. A certain instant of data is continually sampled in the sampling process, but the shape of the signal remains same. You can see here. इन दोनों को भी आप देखो, that is your continuous time signal. It's a discrete time signal or it's sampled form of this continuous time signal. So it is called as sampled signal. Done? Yes.
Yes, ma'am.
Okay. Now, what do you mean by sampling theorem? Yes, friends. Have you heard about sampling theorem?
Yes, ma'am.
जी क्या होती है sampling theorem?
मैम याद नहीं सैम्पलिंग.
Since your sampling rate, अभी हम बात कर रहे थे sampling period, that is sampling time as TS. Then what is sampling rate? That is sampling frequency. Fs is equal to, please note down, that is equal to 1 by TS. And what about omega s? That is sampling angular frequency, that is equal to 2 pi Fs. And in terms of TS, its formula is 2 pi by TS. TS is your sampling period or sampling. Fs is sampling frequency or sampling rate. And omega s is sampling angular frequency. Have you noted? Haji?
Yes, ma'am.
Okay. Now what is sampling theorem? Omega s should be greater than equal to 2 FM. I'm writing here in terms of angular frequency. Your sampling angular frequency should be greater than equal to 2 FM, sorry, 2 omega m if we are talking about omega, that is angular frequency. अगर omega की form में देखेंगे, then it's omega s is greater than equal to 2 omega m. What is omega m? That is maximum angular frequency. Omega s is your sampling frequency, sampling angular frequency. And how to write it in terms of frequency? Fs should be greater than equal to 2 FM. That is sampling theorem. अगर ये satisfy हो रही है condition, that means we can achieve the sampling successfully. Otherwise, there is an overlapping between the signals, and that type of overlapping or error is called as, yes, अगर overlapping start होगी means if the value of Fs is less than Fm or 2 FM, what will happen? Overlapping between the two signals exist, and that type of overlapping is called as aliasing error. Have you heard? सुना है? Yes, friends.
Yes, ma'am.
So what is this? Fs greater than equal to 2w. W क्या है आपकी maximum frequency. You can also write Fm. Please note down sampling theorem. If the sampling rate is equal to twice the maximum frequency, then that type of rate is called as Nyquist rate. If Fs is equal to 2 Fm, then it is called as Nyquist rate. So that's why the sampling theorem is also called as Nyquist theorem. Please note down all these conditions. Done, friends?
Yes, ma'am.
हाँ जी, कर लिया नोट?
Yes, ma'am. हो गया.
Okay. Now what will happen अगर fs की वैल्यू लेस देन हो जाती है या इक्वल टू हो जाती है या ग्रेटर देन हो जाती है? You can see here. First case is this is your minus omega m to omega m. That is your frequency spectrum of continuous time signal जो starting में हमने signal लिया था. If omega s is your sampling frequency or omega is angular frequency की form में है. What about this? That is omega s minus omega m, and this is omega m plus omega s. Now first case is the value of omega s minus omega m is greater than omega m. That means अगर इस omega m को मैं इस right hand side लेता हूँ, that is क्या बन जाएगा? Omega s greater than omega m plus omega m. That means 2 omega m. And how to write it in terms of frequency? Fs minus fm is greater than fm, and fs is greater than 2 fm. Then in this case your signal is like this. Now you can see here there is no overlapping between the signals. Second one is some space is there, gap bhi hai, one signal or second signal. So there is no chance of overlapping is there. That means no aliasing error occurs. और जो ये गैप दिया है that is called as guard band. ये हम aliasing error को रिमूव करने के लिए यूज करते हैं guard band. That is your first case when the frequency fs is greater than 2 fm or omega s is greater than 2 omega m. You can note down. इस केस में कोई ओवरलैपिंग नहीं आ रही. Second case is what will happen when omega s minus omega m is equal to omega m. कि वो दोनों पॉइंट्स मेरे इक्वल हो गए. पॉइंट्स इक्वल हो गए मींस ये दोनों जो सिग्नल्स हैं आपस में ज्वाइन हो गए. एक खत्म हुआ, सेकंड साथ में स्टार्ट हो गया. देयर इज नो गैप इज देयर बिटवीन द टू सिग्नल्स. सो f omega s is equal to 2 omega m. And how to write in terms of frequency f, that is fs is equal to 2 fm. Again there is no overlapping, but यहाँ पे सिग्नल आपस में ज्वाइन हो रहे. So this case is also acceptable in sampling theorem. First कौन सा था? greater वाला. Second कौन सा आ गया? equal to. That's why हम कहते हैं omega s is greater than equal to 2 omega m or fs is greater than equal to 2 omega m. Is that clear? अब आपकी सैम्पलिंग थ्योरम जस्टिफाई है कि नहीं? Yes, sir. Not audible. So that is your definition of sampling theorem. A signal can be represented and it's sampled and can be recovered back. अब जो सिग्नल को मैंने सैम्पल्ड फॉर्म में कन्वर्ट किया कंटिन्यूस टाइम सिग्नल को, उसको रिकवर बैक भी कर सकते हो. दैट मींस वी कैन आल्सो अचीव द ओरिजिनल सिग्नल बैक, बट कब? व्हेन द सैम्पलिंग फ्रीक्वेंसी इज ग्रेटर देन इक्वल टू ट्वाइस ऑफ मैक्सिमम फ्रीक्वेंसी कंपोनेंट प्रेजेंट इन द सिग्नल. दैट मीन्स जो सैम्पलिंग थ्योरम है वो सैम्पल्ड फॉर्म के लिए भी एलिजिबल होनी चाहिए. fs is greater than equal to 2fm और omega s is greater than equal to 2 omega m. एंड सेकेंड रिकवर करने के लिए भी कि हम ओरिजिनल सिग्नल फिर से रिकवर करें. ये रहा जो हमने फर्स्ट केस किया था ग्रेटर देन, दैट इज द केस ऑफ ओवर सैम्पलिंग. उसको बोलते हैं ओवर सैम्पलिंग, जिसमें गैप यूज हो रहा था between the two signals. Second one is under sampling. Under sampling क्या है? When omega s is less than 2 omega m और इसको बोलते हैं aliasing error. What will happen in this case? There is an overlapping between the two signals. दोनों signal में you can see here overlapping हो रही है. That is called as aliasing error. जब less होएगा. And your third case is when frequency omega s is equal to 2 fm. वो हमने already case पढ़ाई है. The next your formula of a Nyquist rate वो भी हम study कर चुके हैं. fs is equal to 2 fm and how to find out the Nyquist interval, that is ts is equal to 1 by fs. Here you can note down this formula also. ये आपका हो गया Nyquist rate. This one is Nyquist interval. Please note down. Done, students? And G noted.
Yes, ma'am.
Yeah.
Okay. ये रहा. Similarly यहाँ पे ये कौन सा केस है? इन दिस केस fs is greater than equal to 2w. क्यों? यहाँ पे गैप है between the two signals. अगर ये ओवरलैप हो रहे हैं that means less than है. अगर ज्वाइन हो रहे हैं तो इक्वल टू है. इसमें भी हम सिग्नल रिकवर कर सकते हैं. So this process is called as aliasing error, overlapping between the two signals. There is overlapping of information which leads to mixing of signals, or we can lose our data, and this unwanted output of process is called as aliasing error. Aliasing क्या है? The phenomena of a high frequency component in the spectrum taking an identity of a low frequency signal. Means high frequency component get mixed up with low frequency component. That is called aliasing error. So it's how we can remove it. To how to improve the aliasing error, very first step is fs should be greater than equal to 2fm or 2w जो भी आपने लिखा है. Second one is use guard band. Guard band gap use करो. Then we can achieve our output successfully without any loss. Is that clear? Please note down these two methods how to improve the aliasing error. 2 marks question, 5 marks question. Describe sampling theorem and aliasing. How to improve it. Done, students?
Yes, ma'am.
This is all about sampling. Your next topic is the receivers. In last slides हमने क्या पढ़ा? ट्रांसमीटर की बात कर रहे थे, AM. अब हम रिसीवर की बात करेंगे. How to receive the data? AM receiver, FM receiver. Now very first is what are the requirements of receiver? अब हमने AM receiver की अगर बात करूं, what is AM receiver? That receives AM wave, जो amplitude modulated wave को receive करता है and demodulates it. अब इसको demodulate भी कर सकते हैं. Demodulate means we can also extract the original signal or message signal back. How? By using the envelope detector. वो हम ट्रांसमीटर में ऑलरेडी पढ़ चुके हैं. और जब FM की बात करें, FM क्या करेगा? Receives FM wave, frequency modulated wave. और इसे हम कैसे demodulate कर सकते हैं? With the help of frequency discrimination method. पढ़ा है हमने? Yes. सुना आपने frequency discrimination method, phase discrimination method?
Yes, ma'am. सुना हुआ मैम.
पढ़ा हमने इसमें ADC में?
Yes, ma'am.
इन सेकेंड पार्ट, आपकी जो सेकेंड पार्ट है पीपीटी का, उसमें आपको मिलेगा. एफएम में हमने डीमॉड्यूलेटर में पढ़ा था फ्रीक्वेंसी फेज डिस्क्रिमिनेशन एंड फ्रीक्वेंसी डिस्क्रिमिनेशन. नाउ AM receiver and FM receiver both having the same requirements of a receiver. What are the requirements? Very first is it should be cost effective. Second one is it should receive the corresponding modulated waves. अगर मुझे AM receiver use करना है, then you can receive AM modulated wave. अगर FM करेंगे तो FM frequency modulated wave हम receive कर सकते हैं. But what is the requirement? Your receiver should be able to tune and amplify the desired station. अगर मैं अब FM receiver की बात करूं, तो आपकी जो frequency है वो tune होनी चाहिए और amplification होनी चाहिए जिस required position पे, station पे हमने signal को receive करना है. Second requirement is it should have an ability to reject the unwanted station. आपके रिसीवर की एबिलिटी होनी चाहिए, कैपेबिलिटी कि वो अनवांटेड स्टेशन को रिजेक्ट कर दे, दैट आर नॉट रिक्वायर्ड इन आवर सिस्टम. एंड लास्ट वन इज demodulation has to be done to all the station signals irrespective of the carrier signal frequency. We have already studied in transmitter portion, carrier signal is responsive for modulation and demodulation. So same here, demodulation has to be done to all the station, to all the frequency tuned up, but irrespective of the carrier signal frequency. So these are the requirements of a receiver. You can note down on your notebook. After this, we will discuss about AM transmitter. Now, any question? अगर ये requirements fulfill हो रही हैं, satisfy हो रही हैं, then the tuner circuit and your mixer circuit should be very effective. Otherwise, again loss of information होएगा, mixing up of signal start होनी हो जाएगी, interference आनी start हो जाएगी, तो आपको correct output receive नहीं होएगी. Done, students?
Yes, ma'am.
Okay. The next topic is RF mixing. Now observe this diagram. In this RF mixing क्या करता है? That develops an intermediate frequency. I am writing here, you can note down intermediate frequency. आपके मिक्सर का काम क्या है? उसने इंटरमीडिएट फ्रीक्वेंसी जनरेट करनी है जिसे हम बोलते हैं IF फ्रीक्वेंसी. RF mixing unit develops an intermediate frequency to which any received signal is converted. so as to process the signal effectively, कि आपका जो सिग्नल है वो effectively process हो। अब इसमें देखो क्या हो रहा है, RF mixing is the most important stage of your receiver. रिसीवर में हम RF mixing block यूज करेंगे। इसमें देखो, can you observe what will happen in signal 1 and signal 2? Is there any difference between these two or same? Yes.
Ma'am, frequency.
Frequency differ is there. That means the two signals of different frequencies are taken in this example. First की frequencies आता है कि second की? Whose frequency is high?
मैम फर्स्ट की।
First की. Why? Because the number of cycles are more in this case. अब क्या होएगा? Two signals of different frequencies are taken where one signal level affects the level of the another signal. एक सिग्नल का जो लेवल है वो सेकेंड सिग्नल को अफेक्ट करेगा टू प्रोड्यूस द रिजल्टेंट मिक्स्ड आउटपुट। हमने एक मिक्स्ड आउटपुट जनरेट करनी है, दैट इज द फंक्शन ऑफ आरएफ मिक्सिंग। अब क्या होएगा, टू इनपुट सिग्नल्स आर देयर एंड दिस वन इज योर रिजल्टेंट मिक्सर आउटपुट, थर्ड वन। क्या हो रहा है इसमें, ऑब्जर्व इट। लेट अस सपोज F1 is the frequency of first signal, F2 is the frequency of second signal. That means output पे क्या generate होएगा? RF mixer is used to mixing up the two signals. I have already explained to you the level of one signal affects the level of second signal. Output पे क्या generate होएगा? F1 plus F2 जाकर add होंगे, जा F1 minus F2 जा सब्ट्रैक्ट होंगे अकॉर्डिंग टू अवर रिक्वायरमेंट, कि हम इनको ऐड कर रहे हैं कि सब्ट्रैक्ट कर रहे हैं। आर यू गेटिंग माय पॉइंट स्टूडेंट्स?
यस मैम।
सो आउटपुट पे क्या होगा, मिक्सिंग अप ऑफ टू सिग्नल्स वेदर इट्स पॉजिटिव और नेगेटिव। तो आपका जो सिग्नल जनरेट हो रहा है दैट इज योर रिजल्टेंट आउटपुट। This is F1 frequency first signal, this is second F2 frequency, resultant output। अगर आप add up कर रहे हैं then it's a add sum of two frequencies। अगर हम difference ले रहे हैं तो so this is observed in the frequency domain। तो पैटर्न आपका ऐसा होएगा, frequency domain में हम बात कर रहे हैं। In this case F1 is greater than F2, that's why the resultant output is F1 plus F2 और F1 minus F2। अगर मैं कहती कि आपकी जो फ्रीक्वेंसी है वो F2 ग्रेटर है, फिर क्या होना था? Yes, if
मैम
F2
F2
is,
माइनस सर।
हाँ जी, फिर यहाँ पे तो सेम रहना था F2 plus F1, बट यहाँ पे F2 minus F1 हो जाना था। Is that clear? That is your RF mixing circuit। ये आपके रिसीवर में यूज होएगा। तो नेक्स्ट हम डिस्कस करेंगे AM रिसीवर। ये रहा आपका मिक्सर, RF IF mixer। IF is here to generate the intermediate frequency. Now if any question up to this point, then tell me. Also note down 2 points, most important terms. One is selectivity. Please note down. Selectivity is the ability of selecting a particular signal. Selectivity क्या है? ये receiver की important terms है। Selectivity क्या है? It is the ability of selecting a particular signal while rejecting the others। जो रिक्वायर्ड है उसे सेलेक्ट करेगा, बाकियों को रिमूव रिजेक्ट कर देगा। नोटेड? यस स्टूडेंट्स, डन?
Yes, ma'am.
Yes, ma'am.
Second one is sensitivity. Please note down sensitivity. Now, what is sensitivity? Ability of detecting RF signal and demodulating it. It has the capability of detecting RF signal, that is radio frequency signal, and demodulating it while at the lowest power level. Done, students?
Yes, ma'am.
AM receiver है next. आपका topic AM receiver में क्या है? Your input is amplitude modulated wave, and at the output we have to achieve audio signal, original signal back receive करना है. यही था कि हम जब ट्रांसमिट करते थे कि इनपुट यहाँ पे आप ट्रांसमिटिंग एंटीना लगाते थे और रिसीविंग एंटीना बैक आपका यहाँ पे रिसीवर पे इंफॉर्मेशन देता था, जैसे सैटेलाइट कम्युनिकेशन होता है सेम. तो नेक्स्ट लेक्चर में भी डिस्कस करेंगे. नेक्स्ट लेक्चर आई विल आल्सो टेल यू व्हाट इज फिडेलिटी. एनी क्वेश्चन अप टू दिस पॉइंट देन यू कैन आस्क. Yes.